The study that we've just published looks at 2 Neanderthal children that lived 250,000 years ago, as well as 1 modern human child that turned out to be about 5,000 years old. And they're all found in the same archaeological site in southeast France. Teeth record environmental variation based on the climate and even where you're growing up. And that's possible because when you're growing your teeth, you actually lock in a record of the chemistry of the water and the food that you're eating and drinking. Because teeth have these tiny timelines, we can relate the chemistry to the growth to be able to actually calculate ancient climate records. We can't do that with any other element of the body. So the first result that was really exciting was that we were able to find on a weekly scale variation and actually identify when the summer was, when the winter was, how long a season lasted, and then we were able to relate that variation to the individual's growth. Another really interesting result was we were able to identify milk intake through breastfeeding in one individual based on a trace element called barium. And we were able to time that to the season. We were able to actually determine that that individual nursed for 2.5 years. Traditional modern humans living in hunter-gatherer environments also tend to nurse their children for about 2.5 years. So this is something we may share in common with Neanderthals. Another surprising outcome was that we found in both of the 250,000-year-old Neanderthal children that they were both exposed to lead during their childhoods, and this happened to both individuals at least twice. So this was really interesting and has never been documented before prehistory that we would have lead exposure during the lifetimes of children. And we think that that must have come from natural deposits in the area. We think the Neanderthals somehow were going into an underground environment, or they were eating contaminated food that was incorporated into their growing bones and teeth. I've worked hard over the years to help people kind of appreciate the different levels of information that you can take from teeth. We've now got the ability to integrate ancient climate data with health history, with nursing history, with illness. And so to be able to get all of that information from a single sample, 250,000 years ago, is, I think, a really unique opportunity. And scientists are coming to appreciate more and more the different types of information we can get.